Hi, good afternoon, everyone. I know it's the first session after lunch, so we'll try to keep you awake. We are going to talk about continuous access evaluation protocol. The previous title was continuous access architecture, but there was so much talk about CAPE, I thought we might as well rename it to this title. So I'm Atul Tulshibagwale. I work for Google Cloud in the Cloud Identity division. And so a little bit about myself. I was one of the first engineers at VeriSign. I was involved in the development of some of the core security standards like X509 and TLS and all that back then. Then I was involved in the development of the Liberty Alliance standard, the first Federated Identity standard that then got consumed into SAML 2.0, and I was a part of that process as well. And so after that, now I'm at Google Cloud and working on continuous access.
My name is Romain Lenglet. I'm a software engineer. I'm working on the Istio service mesh, but I've worked in the past on distributed systems, network security, and identity management.
Awesome. So let's talk about continuous access. We have a very simple agenda. So first we're going to say, why do we need this and why is this important right now, right? And then also take a look at what we are proposing, what is continuous access evaluation protocol, and then also talk about how it can be used in the real world and why, how it will make a difference in our lives in terms of improving the security of what we have. So let's take a look at why we need continuous access and why do we need it now. Right, so back in 2011, Google started on this journey. It pioneered the concept of Beyond Corp that has now grown into an industry phenomenon that is broadly called zero trust. Everybody calls it something different, but everybody understands it as zero trust. And basically, what it means is that people use mobile devices or their own devices, or and they access services that are in the cloud. Which may not be inside the perimeter, and even if you have a perimeter, it is not all encompassing. So as a result, it's fair to say that the perimeter is pretty much disappearing right now. And also, as a result, you instead of attacking a firewall or something which could get you into a lot of interesting resources, the attackers have to shift their strategy and they have to go into maybe the weakest link now becomes the endpoint, where compromising the endpoint actually makes it possible for the attacker to get into some enterprise resource. And to prevent this, what we have to do is make sure that every access that we are doing to every service that is out there in the cloud, on premise, or whatever it is that you're using at the infrastructure level, at the service level, all of those need to be in context. Everything needs to be checked. And it needs to be checked for who the user is, what is the device, what is the location, what is the behavior. All of these things have to be considered when granting access and at every level. And unfortunately, what we are doing today is that the situation is that we authenticate a user once and then let that user continue without any additional checks afterwards. And that is the problem that we are trying to solve with continuous access. So the bottom line here is that the sessions get stale. The sessions are on mobile devices especially, can last for months, even years, right? And as a result, what will happen is, if the context changes, which can happen in a matter of minutes, like a device might get compromised, an app vulnerability may be discovered, a user may be doing something strange that is not really typical of a user. So all those things the context of that access can change in minutes. And yet, using a federated model or using certificates, we are authenticating a user, days before or months before, and we are not taking into consideration all these changes. And so the other property is that in this modern world, the cloud-centric world, we are simultaneously logged into dozens, maybe even hundreds of services. So we need to consider how we can provide greater security in this environment. So the one thing I would like to bring everyone's attention to is that today's networks are what we call as multiple sources of truth. So you may have an identity provider, you may have a service provider, but also you have device management services, you have endpoint protection services. These are like your antivirus kind of services. So all of these have certain information that can affect the context of the access. And we need to consider all of them. And because it's a multi-sourced environment, there are multiple sources of truth, we need something that works beyond just a point-to-point kind of model. So let's look at what we have right now, right? So let's start at the beginning where within the data center we were using web access management. So every access would be checked against the central server. Works great within a data center. And extending that into the cloud has scalability challenges. People at the infrastructure level typically with Wi-Fi and VPN use certificate-based authentication, so which works great. But once the session is established, that session is not reevaluated based on any changes to the device or the security posture of the device or application. And then the most common thing that we do today is federated identity, where at the services and applications layer, we use federated authentication to log into a service provider. And we are logged into maybe tens, hundreds of service providers at any given point of time. But once we are logged in, anything that is changed about the session is not communicated to those service providers. So those are the challenges today with the current alternatives. Now, the one thing that we have today is single logout. And the single logout is something that is supported in SAML at the protocol level, but many implementations in reality actually don't support it. On OAuth side, it is kind of being defined. It's not fully there yet. So there is some work in progress, but it's also a very disruptive mechanism. And it also does not work with certificate-based authentication. So what you have is a sort of a broad hammer. You cannot actually use it to make any fine-grained changes. That is what is needed in today's architecture. It's also somewhat disruptive because if you're at a complex website which has a lot of state in it and you have to redirect, chances are you're going to lose some of that state and you're going to lose some of your work, even if you don't have to authenticate. So that, to avoid all that, what we feel is a better mechanism is needed. And so let's talk a little bit about what the proposed solution is. I'll give a brief idea of what it is, and then Romain will walk us through the real-world applications of it. So what we are proposing is a very limited kind of publish and subscribe model. So instead of the federated model where you establish the authentication and you never talk again, or the WAM model where you keep talking for every access, what we are proposing is a publish and subscribe model where only you communicate only that what has changed. So it becomes a very efficient way of communicating any change to your session data, right? So let's say a service provider may say, well, I have this user logged in. Hey, identity provider, tell me if the user's properties change. Like if the session needs to be terminated or the assurance level needs to be changed. And the identity provider may say, okay, you want these 5 attributes about the session, but based on my policy, I'm able to give you only these 2, right? So there's some negotiation between the service provider and the identity provider here, which establishes what can be exchanged in this publish and subscribe model. So it is, peer-to-peer kind of decided what makes sense to be published and subscribed. Now, the protocol itself is extremely simple. It's, the user accesses a relying party based on, federated authentication or certificate-based authentication. And then there is an expression of interest from that service provider to the policy server. The policy, the relying party may say, I have this device logged into my, Wi-Fi with this certificate. Tell me if anything changes about the device that holds this certificate. So the policy server may say, okay, good. I'll let you know if something changes, right? Same thing at the application layer. If it's federated authentication, you have a SAML request ID, and you say, okay, here's a SAML request ID. Tell me if anything changes about this user who logged in with this SAML request ID. And the identity provider will be able to convey that information when something changes. Now, when anything changes, there is an update. And all these messages are asynchronous, so nobody's waiting for anybody else, but the effect can still be real time. So let's look at what are the benefits here. The benefits are that you are exchanging a very limited amount of information. It can still be a lot at scale, but you're not exchanging information that is unnecessary. It's only what is changed. And at the same time, without disrupting the user flow, without redirecting the user or anything, you are actually able to get a near real-time effect. So because it's asynchronous, nobody's waiting for, the user doesn't have to wait for anything to complete. At the same time, if something changes, that almost instantaneously gets conveyed to the party which is interested in it. And it is decoupled from the authentication. So it is basically, if you're using certificates, federated authentication, doesn't matter. Continuous access will still be able to convey that information to where it's needed. And because it doesn't assume like a IDP-SP kind of asymmetric relationship, the protocol itself is symmetrical. You can basically, it will work with any natural topology where you have multiple sources of truth. Now let's take a look at the protocol, but before we get into that, I want to explain what the protocol is based on, which is this RFC called security event tokens. It's a relatively new standard, but it has been adopted by OpenID Connect, backchannel logout, and by the RISC standard. There's also some stuff going on in SCIM that is using security event tokens. It's basically just a JOT, a JWT, which can contain an event, which does contain an events claim, and the events claim can be free form. It can express a lot of information about the event. There's the standard allows for a lot of extension there. So what we are proposing, the CAPE, the Continuous Access Evaluation Protocol, is based on these security events tokens. And what it does is each service can stand up a single service endpoint. It's very simple. All you have to do is stand up a single service endpoint. It lets you express interest by posting to that endpoint, and it lets you provide updates by doing an HTTP patch to that endpoint. And because we expect the volume of this at scale to be very large, we recommend that we use mutual TLS so that every security event token doesn't need to be signed, because the channel is end-to-end, mutually authenticated. And so with that, we believe that we can scale this up pretty fast to a very large network. And if there are hundreds, thousands of relying parties that we need to communicate changes to, it can still happen at scale without very efficiently. Now, when you express an interest, the server to which you're expressing interest can actually do one of two things. It can say that, you're expressing interest in this session. Let me tell you what is the current state of this session. It can tell you some attributes about that session right now. Or it can just say, okay, I understand you're interested, and when I have an update, I will let you know. So those are the two possibilities in terms of the response. Now, when you're actually providing an update, what you can do is you do an HTTP patch to that same endpoint, and you provide the update, the security event tokens that express the update. And then in response, what you can do is you can say, I've received this update. Here's my response to that update. It can be synchronous. Or you can say, okay, I got your update, and I will publish an update if something needs to be changed. So those are the two ways in which it can be responded. The messages themselves, the security event tokens can include things like context update, a device update, an app update. If the location changes, the service provider can say, I have a new IP for this user, and so on and so forth. So there's a lot of different ways in which these updates can happen, based on who the publisher is and who the subscriber is. So with that, let me hand over to Romain.
So what we want to do now is show you the characteristics of CAPE through two scenarios. The first scenario is about controlling access to a managed Wi-Fi network. In this scenario, the user has a managed device. This managed device has two things. It has a client certificate for authentication, and it has a device management agent running on the node inside the device. When the device wants to connect, it uses a certificate to authenticate against the Wi-Fi router up to the Wi-Fi service controller. And this Wi-Fi service controller is using CAPE to register interest with the device management service here to get the current state of the device from a device management viewpoint. So it registers for updates, and the device management service also returns immediately the current state of the device. Everything's fine about the device. It's not compromised. So the device management service returns OK, and the device gets authenticated. We get access to the network. Later on, the user gets compromised. For instance, the user installs some malware, which disables the device. So the device management agent fails to call home to the device management service. So the device management service will realize that this device is compromised. It makes a decision this is compromised, and immediately updates all the registered service providers, relaying parties, such as the Wi-Fi service in this case. The Wi-Fi service can immediately react to it and block access to the network for this device. So one thing to note here in this picture is that you have no identity provider here. So we want CAPE to be adaptable to many use cases, including cases where here you don't have an identity provider. However, we think that in practice, the policy service, here played by the device manager, in practice this will be played by the identity provider. Because the identity provider is a unique position to actually aggregate and combine signals from many sources, including device management services. So in practice, probably the policy service will be an identity provider. Our second example is about controlling access to protected data, to confidential data, stored in a file sharing service. In this scenario, the user, let's call the user Atul, for instance. Atul wants to access confidential data in the file sharing service. So the user is not logged in, so the first thing to do is to log in using single sign-on. So that involves both the file sharing service and the identity provider. And the file sharing service is also a CAPE relaying party, and the identity provider is a CAPE policy server. So as part of the single sign-on, they will register interest with each other about the session for this user. And everything is fine about this user for now, so the identity provider will return an OK status about the user. So the authentication goes through and the user gets logged in. So the user, Atul, can access the confidential data. Later on, Atul wants some coffee. It's after lunch, like all of us, we need coffee. So Atul goes to the coffee shop down the block. So access is a different network, different Wi-Fi network. But Atul is still logged in. So it uses the same session to access the same file open in the browser and with a file sharing service. But the file sharing service can detect one thing. It detects that the IP address has changed. It doesn't do anything with that, but it will notify, using CAPE, it will notify the identity provider because the identity provider registered for such updates. And the identity provider recomputes, reevaluates the policy about that user and decides that the assurance level has changed for that user and notifies back the service provider about this updated assurance level for the session. And the file sharing service, in turn, will reevaluate its own policies to evaluate whether a user with this assurance level can still access this particular resource. In this case, this is against policy, so the file sharing service will block access to the document access from this network.
And selectively to only that document that has the confidential.
Correct. This is a policy from the file sharing service that's specific to the resource. So one thing that's interesting in this slide is that there are policies in two places, right? The identity providers have their own policies, and the file sharing services, here the service provider has their own policy as well. And CAPE enables reevaluating the policies in both places in near real time to react to changes in the state of those sessions. To conclude, I want to just highlight the two main points about CAPE. The first one is that CAPE enables the reevaluation of policies in near real time when things change about the user, about devices, about policies, etc. The second point is that CAPE is efficient and it's easy to implement for the service providers. We want to make it really easy, push the complexity out of the service provider. And one way we do that, for instance, is by introducing this notion of policy service, which will do the heavy lifting of aggregating and combining signals from many different sources, device management services, etc., and propagating updates to a wide variety of service providers. And this concludes our talk, and we'll welcome any questions that you have.
Just a note about where CAPE is in the process. It's still being formed, so you're getting a very early preview of what the final protocol could be. Everything we have shown here is sort of still a work in progress, and there's discussions going on right now between various companies about what to have in the final protocol. So.
We have a question here. I think we have a microphone. Thank you.
Thanks. So, really simple question. Is there a working group that we can join?
So you can send email to cape-task-force@google.com, and we will add you to a public mailing list. We are planning a whole day session or a whole day workshop in Google in July to finalize some of the, at least formulate some of the initial charter and drafts of the standard. Cool.
Okay, so my question is, what do you see as a topic? Is it the user session or user identity, so that the identity provider can relay any changes to different service providers?
Yeah. You want to? Changes can be about user sessions, they can be about users, they can be about devices, they can be about applications, they can be about policies also. So we are not restricting to any particular level of things, but the end goal is that we want to make the sessions more secure.
So the policy definition language is outside of the scope of CAPE?
What you would do is maybe inside the identity provider, you might have very complex policies, but then you convey a decision in the form of a security event token using CAPE. This one here.
Are the events delivered over HTTP to the service provider? Is that the mechanism for that?
Yeah, HTTPS mutual authenticate.
Well, this needs to be decided.
Yeah.
This is one command protocol. We need to agree on the protocol. But we have an idea of what the primitives are, and this is an example of how to implement the primitives.
True.
Sorry, another question. So, information about compromise, about something that's happened to a user, I mean, this is something that could come from like maybe a proofing service or something like that, where, I mean, I'm not convinced that there's necessarily a traditional session between that service and the IDP going on, but I mean, do you envision that we would still be able to use this kind of approach to get that kind of signal to an IDP?
Yeah, I mean, you're onto something there, because we think that with something like this, the traditional notion of a session itself might get redefined, and it is a multi-sourced environment that we are supporting. So CAPE will just work just the same.
So maybe one way to see it also is that the policy server will have the job of correlating those things. You have a MAC address, you have an IP, you have a SAML session ID, you have all sorts of things, and it's the job of the policy server to actually correlate those things. If you don't need to correlate, you can go talk directly with the device management if you just want to talk about MAC addresses, and that's what you do.
Yeah, but I mean, so one thing that's really important is having a component, if you like, that is in the flow, that is able to determine that something has changed to be able to send that signal. I mean, I think that certainly correlating signals and communicating them to all the interested parties is an interesting problem to solve. But making sure that you can get that signal at a timely point.
Yeah, I mean, some signals will require you to be in the flow, and some may not. Like, for example, if there is an app vulnerability service that detects that, oh, now this application is vulnerable, it doesn't need the user to be in the flow, but it can still publish an update, right?
In the world of many sessions with different domains, how do the different types of session identifiers get mapped together to indicate it's really the same device?
Right. So typically you have some context associated with that identifier. So let's say if you have a device identifier that's based on a certificate, the certificate issuer could be an indicator of, you know, which particular tenant that particular certificate belongs to. Same thing with SAML request IDs. If you know the URL of the endpoint, then you know which SAML request ID you're talking about. So it's all in context, basically. So even if there is one server that is handling like thousands, maybe tens of thousands of customers, we can still identify which one we are talking about.
One last question.
All right. I guess we are running out of time. So thank you, everyone, for spending a little bit of your afternoon with us.
Thank you.